Right, welcome back to Ionic Equations, part 2. It's basically the same thing, but I've just added a few extras, which will help you to manage other parts of the syllabus. So again, the summary of the main points, which I won't go into detail, are exactly what's coming up on the screen, which we went through in detail in part 1. Right, let's look at this Ionic equation. If you want to try it yourself, you can. You can pause it and then play it again. But I'm going to go through the answers one by one, and you can always pause it when you want to do it yourself. So sodium becomes sodium ions, 2H plus ions becomes H2 gas, which is what the Ionic equation. And this is all summarized like we've done it in part 1 of my PowerPoint. The only thing I didn't mention is spectator ions, and that's a new word that you just learned, hopefully. So sulfate ions on the left are aqueous, i.e. SO4, and SO4 on the right is aqueous. These are ions as well, and therefore, because nothing's changing there in terms of state symbols or charge, we call them spectator ions. Explain what is changing in the following, and also like we've done before, which I'm not going to go in detail now. You can do that yourself so you get practice on it, and tell me now the type of reaction that you can see in front of you. So that's a new part of Ionic equations. You can actually identify the type of equation reaction that's occurring, and you will see that in this case this type of reaction is basically called a displacement reaction. The word displacement simply means replace. So zinc has been replaced for copper with the sulfate ion. So we call this a displacement reaction where zinc displaces copper. Another example, and you may remember this from the first slide, the only difference here we got 2, 2, 2, and you can simplify it as 1, 1, 1 by dividing by 2 everywhere. So you can have multiples and you can also have fractions in an equation in case you couldn't remember that from GCSE or you were not told this. However, when you do A2 chemistry, this is not called, the main equation is not called a neutralization reaction because we have certain definitions that you should be aware of in A-level chemistry. And one of the definitions you must know, which is not emphasized at GCSE chemistry, is that you need to produce only 1 mole of water. In order to do that, you would divide everything by 2, and you will come across this equation where you're producing 1 mole of water. So the last equation is a neutralization reaction, but the first one is not. It's all to do with definitions. We've defined it that way. Another one is this one. This is an odd one. I've never seen this on exam papers before. But once you know the principles, you should be able to work it out as this. And this is called a precipitation reaction because you're getting a solid, but this time it's from a gas and aqueous, which you probably may not have met at GCSE. But remember, you're doing AS chemistry, so anything can come up in your paper. And this is a very important test in biology and chemistry. It's called qualitative analysis, i.e. is proving that we've got carbon dioxide gas, because when you see the calcium carbonate produced in the test tube, biologists call it a milky precipitate, but chemists prefer to just say a white solid or white precipitate has been formed. We try not to use milky because we have marked it wrong in an AS chemistry paper before. So please be careful that when you're doing biology as well, you don't mix up the final analysis in both the papers. And this one has two possible answers. In the part 1, I didn't emphasize it, but I'm going to emphasize it in this one now. That's one possible answer, which I done in part 1. The part 2, which is this PowerPoint, you will see that I've crossed out also the sodium ions. Although it's breaking a rule that sodium solid goes to sodium aqueous, that is allowable because really speaking, A state symbol change is a physical change, not a chemical change. So therefore, there's no reaction occurring there. It's just changing in terms of the ions are moving and so forth. So because it's not really reacting, we can actually remove that part of the thing. So there could be two possible answers. I've seen this in OCRA about 10 years ago. We accepted both answers. But the best answer to put down is the second one. So if in doubt, the second one is always the correct answer. So I would stick to the second answer always. And it's good to learn this because there's many ways of writing ionic equations, and in life as well, you'll come across different principles or different ways of doing things, but you have to choose the best one or the more better correct one. So if you become a doctor, you get a final analysis, you want the best analysis or diagnosis for the patient by looking at all the different ways of thinking about the different illnesses the person had. Thank you for listening now. But if you want more detail on this, I have posted this on my TES website. Unfortunately, I will be selling it because it's just more details because it's taken me a long time to do this. And it'll explain each slide in much more detail if you need to. Thank you very much for listening.